sure.
Yeah, Hugues, I'll pass it to you because I think you've got the slides and you've got an intro slide, so we can talk to that.
Yeah. Let me just try to share my screen. Okay, can you see it?
We can see it.
Yep.
All right, nice. Right, yeah. So hi everyone. It's really nice to be here and have the opportunity to present this. So this whole talk will revolve around a demonstration between the integration of PARSEC, which is our project, and SPIRE. So I'll present Paul and myself, and after I'll do a quick presentation on PARSEC. So those of you who don't already know what this is, you can have a brief introduction to it, so then the demo will make more sense. Cool. So I'm Hugues de Valon. I'm a software engineer at ARM, and let me also present to you Paul Howard, who is a principal systems solution architect at ARM and the tech lead of the PARSEC project. I'll do most of the talking during the talk, but yeah, if you have any question during or after, feel free to ask us any question, and we'll both reply. All right. So first, let's see what is PARSEC. So PARSEC is the platform abstraction for security. It's basically a security service that sits in between your cloud native application and your hardware-backed cryptography modules. So usually, if you wanted to talk to any of those modules, and that can be a trusted platform module like a TPM, or a hardware security module, HSM, or even more recently a trusted execution environment. And there are all kind of different TE that you can find. You would have to configure your code to call those specific APIs that can often be really hard to understand. You'd have to go through pages and pages of documentation to know what it's about. And also, if your application is deployed on a node that do not use a TPM but use a HSM, you'd have to have like basically two versions of your code that are configured for the specific cryptographic module that you want to use. And PARSEC tries to solve this problem by being an abstraction in between the two. You can have the same code that will work for any platform, any architecture, and any hardware. PARSEC will do the translation for cryptographic request between any programming language and the actual crypto module that is used on your platform. So to understand a bit better, let me switch to the actual architecture of PARSEC. So in the center, there is the PARSEC service, and on its right side, you can see as providers, they are the specific modules that do the communication to the actual hardware-backed crypto modules, so TPM, HSM, secure elements, or TE. On the left side, the listener is the component responsible to expose the inter-process communication endpoint to the clients. And very similarly to SPIRE, we are currently using a Unix domain socket as well. On the left side of the inter-process communication, you have your cloud native application, which is deployed in the way you want, and which is platform agnostic. So it's this application which will use a PARSEC client library that will communicate to the PARSEC service and do the actual cryptographic request. So on the left side, anything that's on the left side can be deployed on any platform where the PARSEC service is running, and it will automatically work with the crypto hardware that is on the right side. So the same application can work on all of those different hardware without having to change the code. And also with having client libraries that are easy to use in the specific language that your application is in. So usually you would have one PARSEC service running per node, which means that it has to work in a multi-tenant environment, that multiple clients will communicate to the same service, but they will have to, the service will have to do some access control so that one client cannot access the keys, the private keys of another one. And that's done through this way. So each application has a specific identity. But PARSEC does not give the identity of the application. It is given in a way that is agnostic to PARSEC, and you must have guessed that the idea of the demonstration is actually using a SPIFFE to give the identity to the applications. But another way that we have in PARSEC is to use the UID of the applications if they're executing on Linux, and each applications will get this identity, will communicate it to PARSEC in their request, and PARSEC will be responsible to validate it, and then will partition the key store based on that identity, so that the client, for example, in blue here, application A, cannot access the keys of application B. And I will actually show that in the demo. And in the case of Spire, the identity that the client gets from Spire is the actual JOT SVID token, which the PARSEC client library will fetch using the workload API. It will give this token to PARSEC inside the request. PARSEC will validate that the JOT token is valid, and will that will yield the SPIFFE ID of the specific application, and that SPIFFE ID will be used as the identity of the application, and it will be used to partition the key store. The big advantage of that is that if you currently have workloads that are working with Spire and that are given a SPIFFE identity, then basically with really low effort, you could use PARSEC to have hardware-backed keys that are protected from other tenants on your system. And the application itself does not have to give to the library any of the Spire specific information. The client library is responsible alone to fetch the JOT token by itself using the workload API. So that's really a seamless experience. And yeah, let me show you the demonstration then, so that you'll have a better idea of what happens. So in this screen, you'll have like four different terminals. The two on the left represent two different workloads, represented by two different Unix users who have two different UIDs. On the top right, you can see the PARSEC service running. So it's running as a standard systemd daemon. And on the top right, I've already started a Spire server, a Spire agent. And now I'm going to register the two workloads using their UID. So first, yeah, and I'm assigning the same SPIFFE ID as their username. So PARSEC clients first, with their specific UID, so that they can be attested correctly. PARSEC client 2. Okay, so now that both workloads are registered, I'll quickly switch to the systemd window to instead follow the systemd logs. So those are old logs. So yeah, I'll just do that to see the new ones. And now we'll try to use the PARSEC tool. Oh, my bad. Okay, just need to go back where I was. Yeah, to use the PARSEC tool to communicate to the PARSEC service. The PARSEC tool is the CLI command line tool to access to the service instead of having to use Rust or Go, for example. So the ping command is made to just check that the service is alive. And then I'll do a list keys command, which is the command made to list the current keys that are used by this application. And this is a command that needs authentication. So you can see that through this command, what the CLI tool does is that it fetch is just a token through the workload API, sends it to the PARSEC service. You can see that the PARSEC service has validated it and yield the SPIFFE ID, which is a PARSEC client, so the same one as it was registered with. We do the same with the other client. The other client actually already has a key, which is a ECC key pair. And similarly, the validation happened correctly there. Now, if I try to delete the key of the other client with the first one, it fails. So that's all good. It means that, as I said before, you cannot access the keys of the other clients. And now if I try to create one, so with the name Tata, it's created successfully. And if I list it, so you can see the client on the top left has one key named Tata, and the client on the bottom left has another key named Toto. And they can't access each other. So now if I try the similar thing to delete the key of the other client, it will fail, saying that the key does not exist, because both are totally partitioned. Now I will, just to show that list keys actually work, I'll try to delete it. So this one is allowed to delete it and to list it, and there isn't any more key. So that's it, like for the basic, to show you how the partitioning works. But we can do more complicated stuff with the CLI tool, as you can do with any client. And here, for example, I try to sign some text. So it will produce a base 64 ECDSA signature. And something that you would like to do with that is to export the public key so that other people can verify the signature. And it shows the PEM formatted public key. So yeah, so that's really it. A quick demo to show you how Spire and PARSEC work together. Of course, this is a CLI tool, but if you use or Rust or Go clients, you would have much more options, much more parameters to use, and it will be much more fine-grained. So for reference, you can check our code or our documentation in the Parallax Second organization. You have the link to our book here as well, the PARSEC documentation. We are on the CNCF workspace on the PARSEC Slack channel, and we also have a weekly community call where you can feel free to come and ask any question you have. Yeah, and basically that's it for the integration with Spire and PARSEC. And yeah, if you have any question for us, we'd be really happy to answer them.
Great. Thank you so much for doing this. Any questions by anyone? Found this useful? I think Cole and Sachin are definitely going to try it out.
Cool.
Yeah, we are actually currently very interested in anyone who has Spire deployed and is using SPIFFE IDs today and has noted that there is a need to integrate with hardware security as well for private key protection, and is anxious about the portability of that, given that we have this diversity with, you have TPMs, you have HSMs and other ways to do it. PARSEC is a relevant project in that space, giving you portability, a kind of cloud native portability across those solutions. So the fact that we've done the work to integrate with Spire, as Hugues was saying, it means that PARSEC potentially becomes a drop-in for you if you have key management requirements in your projects as well. so do come and chat to us. Yeah, come and join us on the Slack channel, because we're really interested to hear about use cases as well as potential avenues for contribution. So do come and say hi.
Yep. So are you looking to enhance this integration as well? What's the next step on it?
Well, so I think at the moment, the getting to understand some use cases will help us to drive the next steps, right? We think the advantage that we have here is that there is a great synergy. There we go. I've used the S word. Sorry. There is a great synergy, I think, between a portable hardware security system and a zero trust identity management system working together, right? And to have ease of use across those two things. And we really want to continue to refine that experience, right? You kind of saw from Hugues' demo how far we've come. We have the ability, if both of your workloads are in, or well, if n of your workloads are in a SPIFFE trust domain, pardon me, then there's not really anything more you have to do other than consume PARSEC. And if PARSEC is configured to use Spire for authentication, then PARSEC will do all the work for you. So there's no heavy lifting to do. And because PARSEC is also trying to give us these really low friction, seamless and portable access to hardware security, where it's 3 lines of code to sign stuff with a private key, rather than the 2 screenfuls of code you'd need to do it with an interface like TPM or PKCS11, right? We think the combination of those 2 things is really powerful. We want to go beyond having just integrated the projects together. We'd like to be able to demonstrate it, at the use case level. The demo you saw just now was kind of a canned demo. We'd like to be able to move that into real deployments where there is a use case for both identity and hardware security.